first project, we had to spend, I don't know how many hours on site teaching trades how to air seal. This was 15 years ago, but it's not much different. So in designing those construction details, you cannot only aim for the best performance. You need to find the compromises you need to find to really weigh in what is realistic to install and to build.
Enrico, happy to have you on. And we're going to make this a Passive House oriented podcast, obviously. But I think we should, I want to get a little bit more technical. We've touched on the topic before with contractors and facade consultants and architects briefly, generally. But I actually, which I don't normally do on the podcast, I wrote down myths and questions that I want to try to demystify to make this a little bit more informative. But before I tend to jump a little bit too quickly right into it. So before I do so, maybe you could just give a quick introduction. I know you're rather public and very focused on education and promoting education through your platforms, but feel free to share a little bit more from your front.
Yeah, thank you for having me. I'm Enrico Bonilauri. I'm the co-founder and CEO of EmuPassive. We founded a company about 15 years ago in Italy as an architectural practice. I'm a registered architect back home. And when we moved to Colorado in 2017-ish, we stopped practicing architecture and we decided to focus on passive house training, primarily with focus of hands-on passive house training. We came to that because we were designing high performance and passive house buildings. And then when we got to a job site, we found that nobody knew what we were talking about. So that is how we got to do what we do now. We are the main providers of hands-on passive house training in North America at the moment.
It's interesting. So primarily on the residential front or commercial?
We do both because we really try to bring builders and architects together. Our background, where we started from, was more residential, but over the years we have gotten to a 50-50 situation. And our training now, we just released a brand new training curriculum that is really focused on large scale and commercial buildings. And our hands-on training, if you go to our website, EmuPassive.com, really you see the mockups. It's like half side is residential and the other side is commercial. So it looks like a Frankenstein, but it is really designed to have teams work on both type of construction methods using different types of wall assemblies and products. So
I'd like this conversation, and maybe selfishly, to be a little bit more geared towards the commercial side.
Mm-hmm.
But before I answer that question, would your answers vary or differ based on if we are focused on a residential or commercial audience?
It depends. Some answers are going to be different. Like the physics is the same, of course. And I think if you're looking at residential, you're going to use more wood and more low embodied carbon materials. If you're looking at commercial applications, you're going to be using more fire resistant types of assembly, just because the priorities and the scale is different, but the physics is the same. Just like the physics is the same, but you're going to have a very different answers in Florida that you have in Alaska, just because Mother Earth is one and continuous, but you have different problems and different solutions to avoid more condensation, to have performance goals. So the practical answer may be different. It's likely going to be different.
That's kind of interesting that's where your head went, and everybody sort of thinks differently in terms of what stands out to them. But that you said, fenestration would be geared towards wood on the residential side, and I don't disagree. But I think you would see more wood and vinyl, obviously, in residential. But immediately that you went to fire and not necessarily structural.
I was mostly thinking of wall assemblies, not fenestration necessarily.
Got it.
Yeah.
Got it. Interesting. Okay. So I really want to get into the meat of it because we could just talk and ramble, but give me, you need more than 30 seconds. I want to keep it under 90 seconds. Give me the 60-second spiel or pitch on what Passive House is.
Passive House is a series of building standards that really prioritize the quality of the building envelope over the mechanical systems, to deliver very healthy, durable, and comfortable buildings that also need about 80% less heating and cooling than normal construction. Is that under 60 seconds?
That was pretty good. So Okay, well, how do you then apply that principle or frame of thinking, an envelope first approach, call it,
Mhm.
to an existing building retrofit strategy where you are constrained to the mechanical and envelope boundaries you're working within?
That is a very good question. It really depends on if you're working on the whole building at once, so if it is a gut renovation, or if you're doing what we call a step-by-step retrofit. A lot of the retrofits can be, hey, my roof is leaking and I need to fix the roof, but that is the best time to also air seal your roof, to add insulation to your roof, not just fix the leak. Because once you fix that component, it's going to be uneconomical to touch it for another 20, 30 years. So while you do that, it's most cost effective to bring that to passive house level, just that part, and then stage the other parts of the building envelope for later stages when maybe you need to redo your facade because of a very bad hailstorm that damaged some of your glass units. So for retrofits, we have the opportunity to stage and do just partial retrofits. Clearly, you need to have the building physics down to avoid issues with mold condensation. But compared to a new building, you can delay and break down your investment over multiple steps. For example, for a new build, you do need your roof, you do need your walls, you do need your windows all at once. So you don't have a chance to like postpone your window package until 5 years later because you need your windows now. But for a retrofit, you can keep those older windows and replace them 5 years later, but really focus on your wall system, for example, if that is what you need to be fixed right now. So that's a little bit of a more organic approach.
Well, and I would think a little bit of the, and correct me if I'm wrong here, but a little bit of the flaw, in my opinion, or from an outsider's perspective, is that you either comply or you don't. You get your passive house certification or you don't. So it's one thing to say, let's promote healthy, more durable building practices versus these are all the check boxes or criteria you need to meet to get this certification. So, if you're working from a new construction perspective, you're working from scratch, so you can optimize. But
Yep.
in a retrofit application, like you said, you could do your air sealing, you could replace a roof, you can update the lighting, but that doesn't necessarily mean you're achieving certification. Or am I missing something there?
You're missing one option that retrofits have, and that is a certified retrofit plan. So what you do is you analyze your as-built, you assess what needs to be retrofitted and how, like the full picture, and then the first step needs to reduce I cannot remember exactly, I think you're required to reduce the operational energy by at least 20% as the first step of the retrofit plan. But then you can break it down into 2, 3, 5, whatever many steps, and you can then certify the process. The plan gets certified. And then the building will be fully certified just at the end of the very last step, but you have a third-party certification right now as you implemented the first step because you are looking at the whole plan. So it's called the EmuFit plan. EmuFit is the passive house standard for building retrofits.
So let's say you opt for a 3, 5, 7, 10-year plan where you're going to implement all these changes over the course of time. Do you see a future where there will be more government incentives to invest in these deep energy type of retrofit actions or strategies?
That's a good question. It's a very checkerboard situation across the US. New York City has a plan to start fining building owners if they don't reduce their carbon emissions. And I see this more of it's already a stick, more like situation more than a carrot. I'm thinking of other states like Massachusetts is now mandating passive house for all new builds. They may have plans to do incentives for big retrofits, but again, it's more like a checkerboard situation. In Colorado, we have the main utility Excel, that is funding new builds to be certified passive house, and that may be extended in the future to retrofits. I don't have a crystal ball, but I think this can be a good option to have a deeper impact on the built environment, on the existing built environment.
That's actually very interesting what you just said, that I didn't know that. So Colorado is enforcing that you must get the certification or you must just build to a standard that's on par with passive house principles.
Well, um, the utility Excel gives you, I think, $25,000 or $30,000 for each new single-family home construction that you build to a certified passive house standard. Massachusetts requires any building, I believe, over 12,000 square feet to be certified passive house. And whenever you are dealing with municipalities or third-party entities that either give you money or give you permission to build to a certain level, they typically require the certification because it is a third-party verification that you actually comply. There's a lot of passive house-ish buildings out there, but in my experience, if they come close to passive house, they're like hardly halfway there. For compliance, you really want to have a third-party certification,
And is the community striving for that, for more incentives or motives because what you were just describing, ultimately trying to lower operational carbon, whether it's 10, 20, 30, 40%, you can replace the windows, but for a building owner, it's very hard to justify or realize that ROI in a reasonable time frame. Usually you're not doing a full window replacement purely for the energy payback. There's all these other means. You could replace the glass, replace gaskets or replace interface sealant joints. You could put in a secondary film. You could put in these window insert products that people are starting to promote. So all these other maybe more beneficial or attractive options for building owners to see a more immediate ROI.
Well, so passive house does not require the actual whole window to be, or the whole system to be replaced, as long as there's a few performance-based requirements that you have to meet. One is the air seal, that is easy to measure. Other two that involve windows and curtain wall systems and whatnot are the operational energy for heating and cooling, as well as the thermal comfort. That is something that it is an integral part to the passive house standard to have even enough temperatures so that you are comfortable. And that is something that occupants definitely appreciate. It does not really impact the ROI unless you start looking at tenant turnover, and that is something for multifamily that is going to be impacted. I don't have big data because we don't have enough buildings to have that data.
So now we're going to get into the myths and what you just said about you just have to meet certain performance criteria. That's what I advocate for, is you're not limited to certain systems, material types, and so forth. But I think there's this misconception, and it is partially to historically the unknown. I remember in 2018, people saying, "Oh, we just don't have enough suppliers that can fulfill the requirements." Obviously, it's a different story now. But let's look at the first one. It says passive house just means triple glazing.
It depends on the climate zone. The main driver is the thermal comfort requirement that I was referring to, meaning that you have to have even enough temperatures around your room so that your body does not feel temperature differences and you feel comfortable. And in climate zone 4 and higher, it translates to triple pane windows. Climate zone 3 and lower, most likely double pane windows. In fact, when we do a little bit of consulting. Most of what we do is training. But when we do projects in Texas or Florida or Southern California, we get some very committed developers or building owners that want to be the first ones to use triple pane glass in Georgia. We literally had a developer that was excited to be the first ones to use triple pane glass in Georgia. Like, no, you're not, because that's an unnecessary expense. Georgia this was Southern Georgia. It's pretty mild, and you can get to that comfort requirement with double pane glass. And there's literally no reasons to go to the triple pane glass in that situation, but that is climate specific.
Yeah, this one's a weird topic for me because what you said, triple pane windows, and obviously the frame has such a significant impact on it. Yeah. And triple pane aluminum window versus a double pane vinyl window might be equivalent. So all of a sudden that gets a little bit gray and weird. So is it more so we need to achieve this whole window assembly U value?
Correct. Passive house talks about the installed U value. It's a whole window plus it's installed, meaning that the psi values at the interface between the wall system and the window system are also accounted for in that overall U value calculation. And that the maximum U value that is the maximum heat losses are dictated by the climate zone, because you are allowed to have a maximum delta temperature between your window surface and your room average of 7.6 degrees Fahrenheit. So in a milder climate zone, when your delta overall is lower, you can use double pane. We use a ton of non-certified passive house, non-certified windows for certified passive house projects. That is what I like about the standard, is that as long as you meet those requirements with any products, you can make it work. But it is a whole window U value, including how the window is installed. If that makes sense.
Yeah, 100%. And that's actually one of the topics I wanted to focus on a little more, is the psi value. A, what it means, you just defined it, but B, how accurate is the modeling and how well does it translate to as-built conditions when it comes to construction tolerances and shimming and, larger gaps at your interfaces? Is there like a factor of safety that you have to account for?
Well, this is where engineering meets the ground. And like any type of engineering, there is some tolerances built into the model, beginning with how you assume materials to perform. We see some manufacturers of insulation materials claim that spray foam may perform at 8 R per inch, or the wood fiber may perform at 5 R per inch, and those are very, very high R per inch numbers. That is, it may happen in a lab in super dry conditions, and as a consultant, you should not be using those. So that comes a little bit on the consultant to be aware of what is realistic and what is not in terms of performance of materials themselves. Plus, in designing construction details, you want to find a compromise between the ideal of the best performance and the practical implementation. I myself, I'm literally putting together a presentation for a live event in a couple of days about our journey as architects first and then passive house designers. First project, we had to spend, I don't know how many hours on site teaching trades how to air seal. This was 15 years ago, but it's not much different. So in designing those construction details, you cannot only aim for the best performance. You need to find a compromise. And that is, I think, the answer to your question. It's a compromise that you need to find to really weigh in what is realistic to install and to build.
So, very good answer. And I think the reality, rather, of complying is that you need to model it a certain way, the whole assembly, your center of glass, your whole window, the edge of glass, the psi value, and the wall interface. But the only thing that's really measured in reality or on site is the airtightness, right?
Yes and no. Well, measurement, yes. You can take an infrared camera and measure the surface temperatures. And under ideal conditions, that does reflect or does look similar to what you see in the model. That is true not just for the psi values, but it's true for any thermal model that we have. Big picture, looking at theoretical performance versus actual performance. As whole buildings, we have the energy bills. That is another big indicator. And there's a lot of studies showing, how, for example, LEED projects really don't perform as well as they should, as opposed to there's a lot of proof that whole building passive house built and occupied actually performs very well. Very well meaning very close or exactly to what it was predicted by the theoretical model as a whole. So there's a lot of whole building performance. And that is, I think, the closest we can get to the theoretical model touching reality, if that makes sense.
Yeah. Well, my next question is, how often do you actually see that being done, the thermal imaging on site?
Well, that's a great question. During the blower door test, maybe every other blower door test, but that's more like to support the air leakage detection. For the psi value or the thermal bridge assessment, that is too late to do. So that is it's more important to do quality assurance during construction. So to make sure that insulation is properly installed without gaps, shimming is not solid shimming, or if it is solid shimming, must be matched by the model. But if you get to the thermal imaging, it's too late to fix that. Just like for a blower door test, we strongly recommend doing a pre-drywall blower door test so you can actually still fix things. Because if you do your final blower door test, that is the document that you need for certification, but you cannot really do much once all of your building finishes and appliances are in. So it's kind of like, it's too late.
Good luck.
Yeah.
So, all right, next topic, or point rather. I need context behind this one. It says solar gain is always a problem. So in the context of balancing visual light, U factor, and solar heat gain, usually you can't optimize all three. So when it comes to passive strategies, probably in a climate zone 4 or above, how you tackle solar heat gain.
That really depends on the type of occupancy and the climate. Because for schools, offices, factories, you have very high interior gains. And so the passiveness, in a way, comes from within the building, and you rely less on passive solar gains. You also don't want to give up on your visual transmittance, so you want to probably have selected glass with low infrared transmittance and high daylight transmittance to get more daylight in and less heat. But that is again for either high occupancy buildings like schools or high interior gain buildings like factories or data centers where you have a ton of heat coming from within. Now, the passive solar gains is really a priority just for residential buildings, and specifically single-family homes or smaller residential buildings where you have a high square footage of skin per square footage of third floor area, or many square feet of wall, ceiling, floor per person. And so you need to depend more on the passive solar gains to produce the heating. But once you have 500 students in a school, you don't need the sun. Like, you need the daylight, but you have a lot of heat from people, if that makes sense.
So I'm working on a student housing retrofit project somewhere in a heating dominated climate, and aluminum windows, and it's the units are so small and they're operable windows, and we need to hit obviously a certain U factor that you need a ridiculous center of glass U value to hit the whole window criteria. So ended up being triple glazing with 3 coatings to get to the right target. And you get to the point where the U value is so low, but also you basically, it's going to be, with the amount of coatings, it's going to be so dark, you're not going to get any light in the unit. So finding that balance, and maybe it is different strategies. I mean, this is part of, I wanted to focus a little bit on glass in this discussion, especially like thin triples, and VIG has my attention, and how those can be applicable to passive strategies and maybe salvage, alternate means of framing or other construction methodologies.
So we use thin glass, and I want to talk about VIGs in a second. To touch on what you just said, if the window is very small, also the risk for discomfort is very small. And the discomfort is related to radiant asymmetry, so if your surface is cold, but also to downdraft. So if you have basically your room air getting close to a window, getting cooler, dropping down to the floor and causing stratification within your dome. And specifically the second part, stratification, if your window is pretty short, you don't have enough path for the air to get cold enough to drop down. So if your window is very small, your allowance for the U value, you're allowed a higher U value, so you're allowed to have not as good a window, because the damage it does from a thermal standpoint, from a comfort standpoint, is not as big. So there's a lot of that's why we don't really have a checklist to follow. We just model that in the software, and that could allow you to avoid a lot of the 15 years doing this. I've never used a triple coating, So I'm also kind of scared of the implication what you described about losing a lot of visible transmittance, and then why do you have a window in the first place?
Yeah, I mean, do you use a lot of aluminum?
We do. We did more in the past, to be honest. Like right now, we are stepping slowly away from consulting, more focusing on training.
Part of this is I also want to go to curtain wall, which is you're really obviously going to be predominantly, for the most part, shoehorned into aluminum. But on the Windows side, I mean, even in the Northeast, we're seeing a tremendous pivot to other materiality.
Mhm.
And like you're saying, if you are using wood or UPVC, there's not as much stress on the framing component of the system, but especially in aluminum systems, this is where I see the viability of VIG or thin triples or thin quads.
I see the value of both of VIGs and thin triples, even in non-commercial applications. Out of thin triple is a lot lighter, and so it does not stress the hardware as much. So it makes your operable units much more durable, just because the hardware is. Something that shocked me back in the day when I was in school is to find out that the cubic foot of glass, of solid glass, weighs as much as a cubic foot of concrete, because it's the same per cubic foot weight, but just because it's transparent, you may not think about that. And so, if you can move away from the 1/8 glass panes to a 1 millimeter thin glass, you're shedding a lot of the pounds that you don't actually need. So that is something that I really love about thin glass. VIGs, to be honest, we have not used in any projects yet. It has not happened yet. Center of glass sounds awesome, and I think it allows more conventional frames to really boost their performance. Something that I kind of find kind of ridiculous to see a regular triple pane glass put in a frame that is designed to be a double pane, and so those air pockets, instead of being like half an inch or 3/4 of an inch, are squeezed down to like quarter inch.
An eighth, yeah,
Yeah,
quarter, an eighth, yep.
yeah, and there is no performance improvement on that. You're just paying the premium because it's a triple pane glass, but you don't have any improvement on the R value of the glass.
Right.
So the VIGs allow for the boost in that center of glass R value or U value, and that can fit inside a traditional frame. I've not seen that happen yet in commercial or widely available products, but that is where I see the VIGs go to. Something I'm concerned about is the edge of glass of VIGs, because sometimes they use glass or they use metal to do that, and I've not seen any glass edge psi values, and I've not seen any specifics published where I could model that accurately enough instead of just me like guessing the model. So
offline conversation that I'm looking at some stuff with some people. So all right. Passive house means thick walls and deep impractical frames.
I have a T-shirt that says thick walls are sexy. That is not a lie. It's unfortunately worn out, but I do have that T-shirt. And to put my money where my mouth is, the house that we are designing for my family is going to be, the wall's going to be about 2 feet deep. Granted, it is going to be at almost 9,000 feet of elevation in the mountains of Colorado. So not your typical Manhattan application. Yep. I think there's nothing wrong with thick walls other than you get a deeper reveal, but that can also be part of the design. We are going to have built-in benches on our windows. So that, I think it's a matter of how to educate the architects to make that into the design. When I was in architecture school, we got a lot of burns from engineers about making our roofs thick enough to allow trusses to go through instead of just being paper thin. And this is kind of the same thing. There is a need that we just need to make it work, but there's a lot of smart architects out there that make it work today in very beautiful passive house buildings. That is for the thick walls are sexy. Now for window frames, the older versions of passive house window frames, I agree with you that they were very chunky and ugly, but we're talking about window frames designed from the 90s.
They look like doors, basically.
They were like big ass. Sorry, I cannot say that.
Yeah. It's serious.
Yes, they're serious. Contemporary passive house window frames can be as narrow as 2.5 inch. So, because if you think about that, once you switch to a thick wall because they're sexy and to a triple pane glass or whatever VIG, those are all high R values elements. Your frame is the least R value area that you have in your whole building. In fact, the best of the best frame that is currently sold in North America is an R8 frame. If you compare that to a mediocre code minimum wall, it is an R20, your best of the best, very expensive window has less than half the R value of that. And so a way to make them more efficient, they make them very narrow, which means you have less square footage of frame overall, so less heat losses, but they also look very cool because they're very thin. So there are some American-made passive house window frames that they are actually very thin and very aesthetically very pleasing.
So because they're not allowed to get free advertising here, I won't name a name, but why don't we see more fiberglass?
That's a good question. What I know from manufacturers that we used to consult for is that, at least my understanding is that to do molds for the pultrusion of fiberglass seems to be very expensive. So there's not as much R&D as you see in UPVC, for example. At least that's what I believe. I think there's only one. Well, there's a few passive house level fiberglass windows out there manufactured in North America, but I believe that it's the cost of the R&D that may be causing the delay.
This one's actually not written, but I want to. This is on the curtain wall theme. Highly glazed facades can't be passive house certified, but let's go on the notion of think of your traditional all glass facade. The theme or question I want to ask is, how bad is thermal bridging at your spandrel area? The reality of what I see people scream about online versus the reality.
Thermal bridging causes two effects, the worst of which is the risk for molding condensation. And the second, and that is bad because it directly impacts the health of people occupying the building, as well as if there's auto condensation, it may deteriorate the building and cause damage. The second one is the loss in overall performance. I cannot think of specific numbers. I think you can get spandrels that avoid the issue with molding condensation. You also have, if you have a lot of area, you may want to have a different system for those areas because you don't have much R value there, and you may not make it up with the passive solar gain, especially if it is a fully glazed facade. If you're thinking of a bank or an office building, again, those are buildings that mostly thrive on their own interior gains, so they don't need as much passive solar gains, again, in heat-dominated climates. So I cannot give you an overall answer for that.
I'm thinking of a all-glass unitized curtain wall, passive house certified commercial building in the Northeast that, let's say we don't have the details in front of us, but either way, they figured out the detailing there and they made it work. So it's possible. It's not rocket science. The other note here is that passive house drives up facade cost, which I think really the theme of that is they're going to throw money on it because of the unknown. The GC might have another superintendent. He might have contingency. This facade contractor is going to think we need more QA/QC, blah, 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 blah. So It's the fear of the unknown. I was actually with an architect in your area a couple weeks ago, and they said, oh, I didn't know triple glazing was an option. I thought it was way too expensive. And so, right. But coming from the glazing contracting side and the window manufacturing side and seeing hundreds of glass quotes, I'm like, you're little it's the same thing as when designers design the little transom on the bottom so that they don't have to temper the upper light, just the lower. And I'm like, you're saving 40 cents a square foot. It's really, it's so. Do you think it's a lot of misinformation out there that is leading people to stray away from certain paths?
Yes, I think a lot of the mind frame is still stuck to checklists, and to move to a more performance-based approach, it requires more in-depth design and more integrated design, because if you're looking at just the curtain wall system or the facade system, per square foot compared to your minimum compliance is going to be more expensive because it's better quality. But your overall building, especially if it's a larger building, may make up for that by having a much smaller mechanical system. So the economics work very well for multifamily buildings, office buildings, or larger buildings. For single-family home projects, passive house is typically more expensive than your code minimum, but as soon as the scale goes up, you are able to make up for the more expensive envelope with the cheaper mechanical system. And so that to me is more like thinking by silos. That is the problem. You're thinking of just your facade, not your building as a whole.
I got my questions out. Is there anything you want people to, before we share, your events coming up and all that, is there anything you want people to know that either they're scared shitless of, or they shouldn't be scared of, and try to, demystify some of the myths or concerns or, nonsense that is spread out there from time to time?
There's a lot of nonsense, I think, in every facet of human life. And the easiest thing is to be scared of something you don't know. And honestly, when I stepped into Passive House in 2010, windows were the part that I got most scared about, because there were so many psi value, FRSI, solar gain, visual, blah, 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 blah. And I ended up studying it very thoroughly, and we ended up doing consulting for manufacturers. We don't do that anymore, but something I really like about this is that if you are passionate, this is an area where you can really grow professionally, because there's no job checklist that are dropped down from someone high up that you need to comply with. It is really, you can really learn, grow as a professional, because it's all performance based. And I'm really excited about this. And this is, regardless whether you want to go for a specific certification or not, this is a much more in-depth professional approach to making buildings better.
Very, very good sales pitch. So now you could give your plug if they are interested. What's the next step they should take to get that training?
It's a great plug for something we don't sell, because we don't teach consultants. We mostly focus on builders and architects. We've decided to focus on the hands-on part of the training. We do Passive House boot camps in different cities of the United States. We have one coming up in Denver that is sold out in December. The next one is going to be March again in Denver, and we're going to be in Brooklyn in April. But again, that is more about the integration between builders and architects with focus on the hands-on. So we don't really teach any software, any modeling. So I was talking more from my personal passion about the design. If you're interested in the hands-on component, then go to our website, EmuPassive.com, and you will find options for the integrated design and build workshops that I mentioned.
Maybe we'll end up collaborating in Brooklyn in April.
Yeah, I'd love to.
Would be a lot of fun. Thanks for coming on, Enrico.
Thank you, Arjun. I really appreciate your time.